Hello, everyone. So, welcome to one another exciting series, writing the clean code with help of the solid principles. Writing the clean code is equally important uh, as you do the technology selection, as you decide deployment infrastructure, as you uh, select your database. In fact, if you are not focusing on writing the clean code, or if you did not define the pattern and rules of writing the code for your team, then definitely there will be unforeseen collapse in your application. So this is a software lifecycle cost, right? So when you're designing or building a software, what you're doing, you do the requirements and requirement analysis, specification activities you done, design activities are done, coding is done, and then unit testing and integration is done. But when we talk about the maintenance, because every application requires maintenance after some time period. So uh, if for example if you're doing the maintenance and you're scaling up your resources horizontally and vertically, and you're optimizing the database, but while doing these activities you have unstructured or badly formed code, then it's gonna cost you a lot, and you will spend your most of the time in figuring out the scenarios and fixing the codes from all the places in your application. So, for example, if I ask you to cook the food in a kitchen like this, then you have to adjust so many things so that you can cook the food easily. So, this is the example of badly written or unstructured code, because if you have to fix the bug on your such type of code, or add a new feature, then you have to adjust so many things so that you can add the new feature or fix the bug, and unconsciously or unknowingly you will ended up the sudden failures on your production. So before we deep dive in the solid principle implementation, and we know about what the solid principles are and what is the value of the solid principles, I have collected some famous code smells, because it is important for you to know about those code smells. If you are not aware about some of the famous code smells, then you will unconsciously keep writing the bad code. So first code smell is duplication, right? Dry, don't repeat yourself. While writing the code, if you judge that you have to uh, utilize that piece of algorithm or the piece of the code on your different parts of your application, then you should move that piece of code on the central class or on the base class, right? And you can change the behavior of the code with the help of method overloading overriding. So this rule is very simple, and while writing the code, you should be careful, right? Next rule is the inappropriate intimacy. So inappropriate intimacy means that one class uses the internal fields and the methods of another class when you heavily dependent on the internal fields of the another class. So for example, I have two classes here. One is the address class, and I have defined street, city, and a zip code, and then there is one another class, the user. And in order to get the address, right, I'm just heavily using the fields of the address class over there. So this is a bad practice, right? You should not do it, because if you have to use the same full address on your any other class, then you have to repeat that code again over there. So the refactor form of this problem is you hand over the responsibility to provide the formatted address to the address class, and you can use that address class on your uh, different classes, right? So this rule is called inappropriate intimacy, and there is a refactor code. So There is one another famous code smell which is called the shotgun surgery. uh, what happens in a shotgun surgery, you just split the single responsibility among the different classes or the large number of classes. A code which has a tight coupling or poor separation of concerns is called shotgun surgery. So for example, I have different classes here: order class, invoice service, order service, and a payment service class. And in each class I want the total amount of the order, and I just keep repeating the same code across the different classes. So this practice is wrong, right? So you should this is the responsibility of your order class to provide you the uh, total of the order. So this is the form of the refactor code in order to adjust this shotgun surgery smell. So you just, instead of splitting the responsibility of creating the order, you just hand over that responsibility to your order class. In my previous course smell inappropriate intimacy, there was basically lack of encapsulation. But over there, in this course smell, I am violating the principle and creating the poor separation of concerns among the different classes. And now let's talk about one another code smell which is called a feature envy. It happens when a method in one class relies too much on another class data instead of letting that class manage its own behavior, right? So in order to, what the feature envy code smell is, I have created three different classes. One is the customer, other is the address, and third is the invoice. And in my invoice class I'm preparing the shipping label, and while preparing the shipping label I'm uh, creating the tight coupling between the classes, and I am violating the encapsulation and cohesion principle over there. And basically, to provide the formatted address is the responsibility of my address class. So for example, if you need the full name in your shipping label, then it is a responsibility of your customer class to provide the full name. So you must be getting confused that what is difference between inappropriate intimacy and feature envy. I will explain the comparison chart at the end, but the situation over here is a bit different because I am utilizing the data of the class, whereas in my feature envy I was utilizing the internal properties of the class. So this is the refactor form. So I have handed over the responsibility to for provide the formatted address to my address class, and this is how I can get rid of this situation. And now let's talk about one another code smell, which is primitive obsession. So there are two data types here: primitive and non-primitive. When a program relies too much on a basic data types like string, integer, or decimal instead of creating the specific objects for the real-world concepts, it can cause a problem like weak data validation, repeated code, or the poor organization of the code. So over here, I have created three different properties. One is the order ID, which is related to, of course, my order class, and one is the customer name and item name and price and quantity. So for example, if I would like to apply the validation with my customer name, or if I would like to apply the validation with my items or the quantity, then I will ended up creating a messy code with the structure like this. So the refactor form of primitive obsession is, I have created a customer class and then the item class, and I can independently apply the validations over here. And uh, I can apply the validation in my item class as well, and I'm utilizing these two classes in my order class, and which make that code loosely coupled and rather better to manage the different situations. So there are some other core smells as well, but before I move on to those, let's summarize what I have explained earlier. So in inappropriate intimacy, the problem with this core smell creates two classes expose too much of their internal logic to each other. It violates the encapsulation and increase the coupling and reduce the coupling by encapsulating the internal details of the classes. In a shotgun surgery course, well, a small change may require modifying many classes, violates the encapsulation by excessively accessing another class property. A method should belong to the class has the most relevant data. And if I talk about the feature envy, a method in a class is too much dependent on another class data or behavior. It violates the encapsulation and cohesion. If the envied class changes, the envious methods need to be frequently updates, which will lead you to the fragile code. And if I talk about primitive obsession, overuse of raw data types instead of meaningful objects, scattered logics you have with this code smell, and you have to, uh, adjust one change on so many classes, and you have the repeated validation everywhere. So there are some other code smells as well. Let's talk about those. One is the long methods. By books, your methods should not go beyond 70 lines, but it depends upon the logic you are writing. But you should avoid to go beyond the 70 lines. You should avoid the big classes as well. The rule which is written in Martin Flower's book about the length of the classes is that it should not exceed more than 500 or 600 lines, and if it exceeds, then you need to split it across the different classes. Useless comments will definitely increase the readability issue in your code, right? So your code should be self-explanatory. And how it will be self-explanatory? You should avoid the poor naming, right? So the name of the method and the classes should be self-explanatory, and if I read the name of the classes, I should understand the purpose of the method or the class. And then usage of lots of switch and if else statement will increase the complexity in your code, so you should avoid it as much as you can. The god classes, these are the classes where you just accumulate all types of logic in one class, and which will definitely create a lot of complexity and make your code more fragile. So hopefully you understand these all the code smells, and it will make you conscious while writing the code, and you will ended up a well structured and well formed code. In our next section, we will talk about the solid principles, and we will see that how the solid principles play the vital role in building the good architecture of the code.